Hi, what I'd like to do is talk to you about something called average rate of change. Believe it or not, if you've taken Algebra 2 or even Algebra 1, you've heard of this before, you just never called it average rate of change. The more commonly used word is slope, which you learned about. You usually denoted it with the letter M, and you'd find that by doing change in y over change in x. However, typically in more advanced calculus books and so forth, and some of your pre-calc books, average rate of change is expressed this way. F of b minus f of a over b minus a, where a and b are the endpoints of an interval containing x values. Best to show this by doing an example. So our first example is going to be find the average rate of change, which I will abbreviate Aroc, of f of x equals x squared plus 2 on the interval 3 to 5. Okay, so here's how we proceed. This 3 is going to be A, and that 5 is going to be B. That's typically how we acknowledge things. We usually let A be the left endpoint of the interval and B be the right endpoint of the interval. All I have to do is follow the rule. So it's going to be f of 5 minus f of 3 over 5 minus 3. Now to perform f of 5, we take the number 5 and plug it into our original function. So we take 5 and substitute it into our function. We get 5 squared plus 2, which is 27. Minus, now we take 3 and plug it in. 3 squared is 9 plus 2 is 11. Over 5 minus 3, which is 2. Next, just subtract 2 on the bottom, 16 on the top, get a final answer of 8. And 8 is our average rate of change for the function f of x equals x squared plus 2 on the interval 3 to 5. So you might ask, what does it mean to find the slope or the average rate of change of a parabola between 2 points? So let's draw a picture. Here's our parabola, our x and y axis. Here's our parabola. Looks something like this. F of x equals x squared plus 2. And what we did was we found the point that went along with x equals 3. And we found another point that went along with x equals 5. And we actually found the slope of this little green line that connects those 2 points on the parabola. These kind of lines, where you take 2 points on a curve and connect them and draw the line or line segment between them. This line could extend further if we'd like and just be a line and not a line segment. But those kind of lines are called secant lines. So that's how you do average rate of change. You can do it for any function, provided you're given 2 x values.